Welcome again to our continuation of our topics. Now we start with the new topic of Form 4, which is the topic of probability. This one, we start with the idea of real life situation in which people are used to do things and then expecting some outcomes. So we say at the end of this topic, we will be competent enough and we will say we are done with the topic if we will be through with the following subtopics. First of all, we need to understand the concept of probability and its meaning in the real life situations. And then we'll have to check terms used in probability. Also, we'll have to know probability of an event. Then we'll have to check the idea of probability of sure and impossible events. Then we'll be touching the idea of probability of an event to occur and that not to occur. Then we'll be checking the idea of counting techniques, compound events, in which inside of the compound events, we'll be looking at the idea of inclusive events, mutually exclusive events, independent events, and dependent events. And we will be concluding with the part of addition and multiplication law of probability. Inside these terms, we'll be extracting so many concepts involving the idea of probability. Now, starting with the concept, with the definition of probability, we say, when one is living today, there is a possibility of not being living tomorrow. So you can be dying tomorrow or you'll be still living. You are attending an exam, there is a possibility of passing and not to pass. You are competing for an interview, looking for the job, let's say. There is a possibility if A is getting the job, then B and C will not get the job. So the condition on that, which deal with the idea of chances or uncertainties, is the one which classified as a probability. So simply we define probability as the branch of mathematics which deals with the study of chances or simply deals with the study of uncertainty. So when we want to check the idea of terms used in probability, there is this thing we call probability experiment. Probability experiment is simply any process with a finite number of observations. So whatever you are doing, something which the result is known, we simply call it as probability experiment. So here is an example which is clearly trying to elaborate and giving the hint on terms or examples of probability experiments in which the observation is well known. So, for example, when you toss a coin, you toss a die, mind you, is a six-sided polygon with numbers marked from 1 up to 6. So, upon tossing a die, we expect either 1 or 2 or 3 or 4 or 5 or 6, one of the number to appear on top. So, in that case now, we say that is an experiment. So tossing a coin, for sure we know that just an action of tossing a coin is simply referred as a probability experiment. Playing a football match, so you have Chelsea and Manchester United, let's say, at Stamford Bridge. So wherever the team is playing a match, football match, let's say, is a probability experiment. So attending an interview is an example of probability experiment. Doing an exam is a simple example of an experiment. Becoming pregnant. Once you meet a woman is pregnant, that is a probability experiment. So we can be making many examples of probability experiments in real life situations. So we have another term. This one is referred as outcomes. And outcomes are the results expected to occur during probability experiments. So the result expected to occur during probability experiments, we simply refer them as an outcomes. So let's look here. For example, when you're tossing a die, the outcome is either 1 or 2 or 3 or 4 or 5 or 6 to appear on top. One of the number can appear on top. So those are the possible outcomes. We also will say, let's look when you're tossing a coin, the outcomes is either a head or a tail to appear on top. So these we call outcomes. So for a team playing a football match, expecting the outcome, 3 possibilities likely to appear, one of it. That is, a team can win the match, or there is a possibility of having a draw or losing the match. So 3 possibilities. That is what we say. So the outcomes are the results expected to occur during probability experiments. So let's say, for example, attending an interview. So the outcome is either qualify or not qualify an interview. So there is a possibility that you'll be qualifying for an interview or not qualifying. So 2 possibilities are likely to occur. One of them, doing an exam. Only 2 possibilities exist for a student or someone doing an exam. You will always pass or fail. Only 2 possibilities. There exists no more beyond than 2 possibilities. For one is doing an exam. So the possibilities, or we say the outcomes, is either pass an exam or fail an exam. So this is what we say. So becoming pregnant, 2 possibilities for an outcomes, either a male or female kid to be born. So we are expecting a kid of a single sex. But when the woman is not yet delivered, so we are expecting either male or female kid to be born. And not beyond that. We will be not having a kid with 2 sexes simultaneously. So here we say, drawing identical objects from the container, the possibilities will be subject to the color of the identical objects present in the container. You may be having different colors, let's say white, green, blue. So upon picking randomly an object which are all identical, so you'll be picking a color subject to the color presented in the container. So this is what we call about the concept of outcomes. So let's now continue with the other term on this part. So another term here, student, is referred as a probability set. It is having another name we also call a possibility set, or sometimes we call it sample space. We say this is a set of all outcomes during probability experiment. So during probability experiment, we have the outcomes. So writing all the outcomes in queued brackets with a special set, that set is referred as a probability set, or simply denoted as sample space. We always denote it set by capital letter S, which abbreviates sample space. So from the outcomes above, the sample space will be, for the probability experiment of tossing a die, we know the outcomes was 1, 2, 3, 4, 5, 6. So writing the outcomes in set form, denoting by S, this one is, we call it as a probability set, or simply as a possibility set, or simply as a sample space. So from the probability experiment of tossing a coin, the possibilities was head and tail, head or tail. So writing it in queued brackets, abbreviating using S, we call sample space is head or tail. And in the same way, for the team playing the football match, the possibility was win, draw, or lose. Now writing in a set form called sample space equals 2. In the same way, for a student attending an interview or anyone else, so we expect to qualify or not to qualify for an interview. Now writing it in set form, this is the sample space, or simply probability set. In the same way, for doing an exam, pass or fail, writing in set form will be appearing like this. For the woman who is pregnant, becoming pregnant, the sample space possibility was male or female. Now writing in set form is appearing like the sample space male or female. Drawing identical objects from the container, the sample space will be subject to the color present in the container. It will be defining the sample space for that particular probability experiment of selecting object. The next topic of Form 4 series of topics. We are now switching with the topic of linear programming. This one as the topic itself, linear programming. So at the end of this topic, we need to have the background of the topic.